Good morning or good afternoon, whatever the case may be, and welcome everyone to this first in a series of Cloudstreet webinars focused on network slicing in both theory and most importantly in practice, and the profitable path to this next generation of telecom. If you're just joining us, I want to take a brief moment to introduce ourselves and the format and agenda of this presentation and say a few words about this important technology and model. My name is Brendan Walsh, and I'm the head of marketing for Cloudstreet. I'm very pleased to be joined by our prime presenter and a true visionary in this area, Mika Skarp. Mika comes to us following nearly 2 decades of work pioneering innovative telecom business models, an executive engineer at Nokia, both in Finland and later in Silicon Valley. Mika was the founding president of the WiMAX Forum, a consortium of companies and business leaders focused on supporting and promoting that standard. While at Nokia, he headed up the Village Connection, a novel program dedicated to expanding wireless coverage in remote regions in the developing world. So welcome, Mika. Our webinar today will run for approximately 40 minutes, and we invite your questions throughout, and we'll try to field those in chat. We'll also provide some time at the end for Q&A if there are any follow-up questions at that point. No doubt network slicing's impact will soon be felt on the scale that the very smartphone has. Our devices will not only seem at once much smarter, but in the context of application-aware networks that we speak about, this is going to provide a complete command of a fluid interplay of experiences that will come to define the digital lifestyle. This is a really good starting point for a discussion of network slicing and its important mission with the inauguration of hybrid 4G and 5G networks user experience. While much of the discussion on network slicing has revolved around the frameworks for its delivery and the use cases they will enable, there's been relatively little examination of the user journey. And that's the mission of today's webinar, and indeed our company. Cloudstreet was launched just 4 years ago, but was the world's first company to provide commercially available network slicing solutions. So we come to this topic with some good and practical pedigree. So at this point, I'm just going to quickly run through the agenda and then pass over the controls to Mika. We're going to just pass through the introduction section. We're going to talk about why network slicing, technology and waiting, and we're all very excited about the coming years as it becomes deployed. We're going to take a quick look at some market forecasts, some of the opportunities that we see. We're going to contrast best effort with orchestrated QoE, which is what network slicing is really all about. We're going to talk through some of the flavors of network slicing. Then we're going to talk about how we do it, and then the elephant in the room, which Mika is going to address on the subject of net neutrality, and then take a quick look at the overall roadmap. So that's where it's at, and I'm going to, with that, hand it over to Mika Skarp, and hope you all enjoy the webinar.
So thank you, Brendan, and also welcome from my behalf to the Cloudstreet network slicing webinar. So let's get started. The network slicing, it has been a buzzword of the year in the mobile telecom industry. It actually started in the February in Barcelona, where it was kind of launched big time. We have been doing it for a while. I don't know if we were the first one, but definitely one of them in the industry. And now we are in definitely a good company, so we can say that everybody's talking about network slicing. So here we have couple of quotes that we have picked up from the media to the presentation. So from Deutsche Telekom to Huawei, to Ericsson and Telefonica. And here, if you go through these quotes and also the other quotes, the very interesting part is that they are talking about the business, that the mobile business has been a little bit struggling. It hasn't been growing during the last decade that much, and network slicing is actually seen the vehicle that we can actually turn the industry around and start growing again. And it's very important to recognize that it's not so much about the technology, but it's about the business model, that how do we actually provide the services, how do we sell the services from the network. So that said, it's also said that it's 5G that is actually bringing this great thing to us, and we are actually saying that it can be done already in a 4G. And the reason why that is very important, it's illustrated in this picture. This is the data coming from the ITU Annual Broadband Report 2016. And if you think about the history, we have seen this same graph with 3G and also with the 4G. So whenever you introduce a new technology, any new G into the market, it will actually take 5 years or 10 years time before it's materialized, before it actually catches the previous generation. So here you can argue that 5G subscription will increase faster. Well, they might, but still in 2022 it will be still and significantly less 5G subscriptions globally than LTE 4G subscriptions. So basically, if we really want to start changing our business ecosystem in the next coming years, we have to start with something that we have, and we have to start with LTE. And the good news is that LTE is actually capable of delivering network slicing very well, as we will show in this presentation. So this is just showing that how important it is to get going right now. So what is network slicing? How do we define it? So this is the starting point is here. So we have basically our existing network. We have hundreds, thousands, millions of apps there, and they are using the network, and we are basically providing the same services for different applications. Although we know that some of those applications, they work better and some of them work worse. And the reason and we also know the reason that they are given the best effort from the network. So the capacity might be plenty for some of the applications, and it's not enough for some of the applications. And also from the business model perspective, we are basically pricing them equally. So there is no differentiation between how you are actually using the network. And now with the network slicing, we are about to move to this kind of a situation where we have different capacity classes in the network. So there will be the best effort class for sure. So best effort is very good for synchronizing different accounts. So your email account, Facebook account, Twitter account, and reading some data from your, for example, electrical meter or so, that it's not time critical and there is no basically any capacity requirement. So that will stay there, and it will serve the certain applications. But then moving in the value chain a little bit higher, so there we have a capacity sensitive traffic. Capacity sensitive traffic is such that we need to get a certain amount of traffic through the network in a given time. So that, for example, in a 1 minute period, 10-second period, we have to have a certain amount of capacity going through. We are not worried about the delay or jitter that much because we are doing the buffering. So basically, and if you think about a video application like Netflix, so we are downloading the stuff to the buffer, and then the video is actually shown from the buffer to the screen. So if there are some glitches in the connection, it's not visible for the consumer. And then when we move to the next level, there is a delay sensitive. So basically those kind of applications that we can't buffer. So for example, a good example is a voice. So this kind of a voice conference is such that buffering is not, we are not able to do the buffering because then we would kind of lose the synchronization. Then the augmented reality is also a very good example. Critical communication, Internet of Things, those kind of applications where we are measuring something, and based on those measurement results, we are controlling some engines or electrical motors or so on. So there the buffering is off. The network actually is very capable of delivering different kind of different kind of traffic classes. And the good point from the business perspective is that these different traffic classes, traffic categories, they have a different value. So then you can also price them differently. And customers are actually willing to pay extra if there is an SLA in place. So if you can guarantee that the capacity is delivered on these manners, then the customer is willing to pay extra. This model actually it's very universal. It's something that is visible in every single network in the world. Doesn't need to be a mobile network as such. So this in very short. So basically from the network, from the one network we want to deliver different service classes. That's what the network slicing is all about technically and commercially, because we have a different service classes, we have a different price points. So that's a fairly straightforward and easy to understand and agree that yes, this is it. But then when we go and one level down, we start to see some flavors. So if you follow the network slicing discussion on media at the moment, at least these 4 different terms are used. We are defining them these terms just that we are able to discuss on the same topic. So the vertical slicing here means that it's the business vertical. So it's basically your customer segment, that who do you sell your service. So it can be a public safety, it can be an autonomous car, it can be industry, insurance industry, and so on. The horizontal slicing is then something that is the most talked during these days. So we are talking about the technology, that how do we actually do the slicing, what kind of elements we are dedicating for the slice, and what kind of parameters we can then achieve. So good example is in the 5G discussion about the 1 millisecond round trip delay, so that if we do things accordingly, so then in the 5G we can achieve the 1 millisecond delay. So that's the technical level. So how do we do things? Then we have a static slicing. So that basically means that we have a custom-made device for the single purpose, and so that it's a device that is designed to deliver a one use case. So we have done this quite a lot. So we have been doing an TV productions in the commercial LTE network here in Finland over 3 years. So basically we have built a transmitter that is using the LTE network, and that transmitter is used only for TV production. So connecting the TV cameras from the stadium to the studio. And then we have the dynamic slicing. So dynamic slicing means that we have one device and it has a multi-purpose. So then we can actually change the profile accordingly what is needed. So that's with a good example of multi-purpose device is a smartphone or the wireless router that's we can have it at home or office. So these are the basic terms and how we are defining them. So the vertical slice, there we have in this example we have 3 different slices. We have a public safety slice, and then we have the IoT slice, and then the IPTV slice. And this is something that how we can illustrate this very well. And now when we jump to the horizontal side, there we actually have these categories of traffic: best effort, delay sensitive, and capacity sensitive. So when we are designing a slice, we have to actually think about is the slice for the best effort, is it delay sensitive, or is it a capacity sensitive? And then what kind of a traffic we are going to have on it. So is it a symmetric traffic, like the typical voice call, virtual meeting, or so, or is it something that we are downloading stuff like watching TV, or is it something that we are uploading stuff like the body cameras? So these are the technical parameters that we can actually play with the horizontal slice. As you can see that there is not actually direct link between the horizontal and vertical, and I will show the example that how it actually goes in the public safety domain. So imagine that you have a police officer. So the police officer is using an handheld device that is used for several purposes. So he will start on the break. So he's in a cafeteria, enjoying the coffee and eating the donut. Maybe going through his work emails and looking what's going on in the Twitter. So that's a typical situation where the best effort class is used, and that's working very well. Then he will get a call, the push to talk call from the dispatcher. So the dispatcher will tell that, okay, police officer 621, please go to the incident here and there. So that's the profile. What we use there is a symmetric profile. It's not that much of a capacity, but it's very delay sensitive. Okay, so then the guy will jump on his car. So the body camera is studied. So body camera is used to capture what a police officer will actually do. So yet another profile is used. So in the body camera case, we need an uplink capacity, and we need that quite a lot. We need that something like 2 to 3 megabits per second, and the downlink requirement is not that much. Then when the officer will actually arrive to the incident scene, he might want to download data about the building that he's about to get in, so that he can actually see that who is living in the building, if there is some hazardous materials and so on, if there is something special information that he needs to know. So here we can actually see that these kind of use cases, the only way to go and provide all these use cases properly is that we need to change the user profile. We have to do it dynamically, and especially when we are in the very large incident. So there we have hundreds of police. If they all come in with their body cameras on, it will actually congest the network, and that's something that what we don't want to do. And that's the point, that we have to be also able to turn off the profiles just to prevent the network not going to the congestion. So summarizing here is that we have to think about the business side, who do we sell, and then we have the different technical elements, how we can do it, and we have to do it in most of the cases dynamically, because then we can actually serve all the use cases the optimum manner. Okay, so then the obvious question is that, how have we done it? How are we doing it? Because we are doing it already today. So we have developed a new network function called Dynamic Profile Controller, DPC. And DPC has an open northbound API that the application can actually call for the special service. And before the application can make the request to DPC that please give me a special service, it's measuring its RF condition. So if your RF condition is poor, it really doesn't matter what kind of a QoS settings we are giving to you, because it's not gonna help anyway. But if your RF conditions are good, you are allowed to send, or let's say that if the RF conditions are such that the service can be delivered over those RF conditions, then the request is sent to the DPC, because the different applications, they have different requirements, and different requirements turns to the different requirements towards the RF conditions. So the request is sent to the DPC, and then the DPC will actually say, I'll take a look at it, that what is the location of this new request, and based on that information, it will then make the decision if the one additional special user can be added into the requested slice. The way that the information then inside network is distributed, there we are using the QCI parameters. So we have created different QCI classes for different services, and then that's the vehicle that the information is delivered to the node B, where the QCI class will impact the scheduling weight, and then the IP transport, where the priority IP traffic priority is impacting the IP pref value. So that's the way that it's done. So then let's have a look at it. What kind of features do we have there? So we can actually set up the limits for the slice, so that we can say that IPTV special services can't use more than 25% of the capacity of the cell. IoT 5%, public safety 20%, and then the 50% is reserved for the best effort. The very nice thing here is that if we don't have any IPTV users, so then the best effort users, they can use also that part. So in no way we are actually wasting capacity ever. And the additional thing what we can do is that we can actually go inside the slice and differentiate the service between the use cases. So in this IPTV use case, the obvious subclasses are 4K, HD, and SD. So and because the request is made by the application, so we can be very precise what kind of subclasses we have, and that can be handled by the DPC as well. From the user perspective, so as a user, how do I actually create an dedicated bearer request? It's that we have a default bearer when we are in the network, so that's given when we are connected to the network. And when the certain application is studied, we are using the default bearer to make the request. So we are calling it signaling. Strictly speaking, it's not signaling, it's just the user plane traffic, but for us it is. And then if the DPC is actually approving the request, it will then send a command to the core network to create a dedicated bearer. And the dedicated bearer is created only for the application that is actually requesting it. The application, there are three ways to do it. So we can have actually a Cloudstreet trigger application on the device. And the trigger application, it can be taught that, okay, follow these applications, and when they are activated, then create a request for the DPC. Or we have also developed an SDK that can be integrated into any application. That's an app library, and when basically the logic is that when that application is activated, then the dedicated bearer request is delivered to DPC. And as said in the beginning, we have actually also the open API, so basically you can create your own communication with the DPC without our SDKs or applications. So that's in the high level, how does it work technically. But before we move forward, there is this big elephant in the room, and that's net neutrality. you can't have a network slicing presentation or the conversation without starting to think about discussing about net neutrality. And net neutrality is a very, very important thing from the society perspective. So we believe that everybody has a right to access to any information that is out there. It's not our job to try to limit that. We have gone through these discussions in many countries in Europe, in the United States, in Brazil, in India, in Bahrain, and we can say that they are fairly similar. So these rules around the world about concerning the net neutrality are similar. This example what we have here is from Europe. In Europe, we can do network slicing for two purposes. The first purpose is a traffic management, and then the second purpose are special services. So if we first look at the traffic management measures, so here the starting point is that objectively, when you look at the need objectively, that it has to make sense. So that's a good example is online gaming. So when you are playing online over the mobile network, it's not actually that capacity demanding, but it's very jitter sensitive thing. So you can actually learn how to deal with the delay. So we are talking about 20 millisecond, maybe 30 millisecond delay. But you know, if that varies a lot, it actually destroys your gaming experience. So because of that kind of a need, we can create a different QoS profile so that when you are playing, that profile is on. It has to be, when doing a traffic management, it has to be non-discriminatory, so that you are not allowed to favor, let's say, PlayStation 2 over Xbox. So basically, you give the similar kind of access to those special profiles for both gaming consoles. You don't need to monitor or you are not allowed to monitor, but you are allowed to make the application to request the service. And the service, the special QoS has to be on only as long as it's needed. So when you stop playing, this special QoS treatment has to be stopped. And it has to be also limited in size, that you know how much of this kind of a players you are allowing into the cell at the time, so that people have a general access to the cell as well. So if you look at these requirements, this is a 100% match that what we have done. Then if we go to the next class, specialized services. So here the need is something that you can justify it from the society perspective. So a good example is that if you want to provide the linear TV service over the mobile network. So basically that you have the similar kind of a customer of experience over mobile network when you are watching TV than when you are watching the linear TV. These services they need to be pre-approved by the local regulator. These services percentage, that how much of the capacity of the cell is allowed to be used, has to be limited. And then it has to be also something that the customer has opportunity to not to use the slice, not to use the special treatment. So it has to be controlled by the end user. And this is also something that what we are doing. So now looking at both these cases, we can say that dynamic profile controller technology is 100% aligned with the regulation or the net neutrality regulation in Europe. Okay, so let's have a look at that the demo. That what does it actually do and how does it actually work? So starting point is very well known by all of us. So that's we have a cell there. We have a 100 megabits downlink capacity, and then we have a 1 megabit per user. You know, we have 100 users, so we have a 1 megabit per user roughly. So that's a very good capacity for the Facebook. But then if you are trying to watch a video over it, it's not actually that great experience, even if we are using a buffer. So this actually underlines the fact that even if you have the same QoS settings, the quality of experience is different depending, you know, what you are trying to do with that capacity. And our target is that the quality of experience is the same independently what kind of application you are actually using. So first, obviously, we need a couple of users. So let's say that we want to create an IPTV users that are really happy about the service. So for them, we create a slice, and we don't create only an OTTV slice, but we will create 3 different subclasses. So we have a 4K, HD, and SD. And now we add a couple of users there. So we have 1 4K users and 2 HD users. And with these numbers, we end up to the 17 megabits per second. That's well beyond the limit that what we have in this cell, the 40 megabits limit. So everybody's happy. It's also interesting to see that these users who are using the network on the best effort manner, they are not suffering actually that much. So the quality of experience when using Facebook or Twitter or LinkedIn on this 830 kilobits per second compared to the 1 meg, it's not actually changed at all. So they are still very happily using the network. And now when we start adding users, so then we have, you know, three on the 4K, 3 on HD, and 1 SD, and we are getting closer. So we have 39 megabits per second. And now when we take the next step, we will go over the limit. So now we had a user requesting the HD capacity from the slice, and in this general typical network, today's network, this is actually a congested situation. So we have more demand than what we have the capacity. So basically, the cell throughput will drop dramatically, and there is a lot of retransmission happening. And so you don't actually want to do that. But for DPC, this is the decision point. So let's take a look at the options that what we have. So obviously we can say first that you know, you are not, dear customer, you are not allowed to get into the slice. We are, you know, overbooked. But you can of course use the network using the best effort class. Or what we can do, because we have these subclasses, we can actually move users between the subclasses and make room for this newcomer. Or we can say that okay, this is now the prime time show, so we will increase the slice a little bit, and that way make room for the newcomer to enjoy the slice. Or we can have the advanced version and then actually move the user from the from this network to another. This could actually be the case, for example, where we have a hybrid router at home, that it has an 4G backhaul and also the ADSL, for example. And in this case, we actually selected the option number 2, so we moved the users from the 4K to HD, and that was the way to get users into this new user into the slice. And even in this case, the rest of the gang is still doing fairly okay. So this shows that when treating traffic on the clever way, we can actually have much more happier customers, happy customers that are really enjoying the quality of experience. And here is another one. So now we are inside home, and we have a router here it's using the LTE as a backhaul, and we have mom and dad. We have created a TV slice for them, 5 megabits HD slice, and now the son will start downloading the game, and the daughter is using the Facebook. Now, as soon as you start downloading something, if the mom and dad was not on the different slice using the dedicated bearer there, this download would impact their experience significantly. I think at least I have a lot of experience of that at home. That's when I'm doing something and then the rest of the family is doing something else, my experience is compromised. But in this case, it does not. But this is not all. We can actually go one step further, and we can actually create an own slice also for the son without increasing the total amount of traffic we are using. So when the son will actually start playing the new FIFA game, he's created a different kind of a slice that is optimized for the gaming. So then we have a very good gaming experience for the son. Mom and dad are also using happy with their TV experience, and daughter has the best of both. Facebook still going on, and that all is happening at the same time. So given that, so where are we going? That's the with the 4G network slicing, we can do it, and then the 5G is coming in, and obviously, you know, over the time it will take over, but it's gonna take a decade or more from today's situation. So here we have the dynamic profile controller and LTE network, and we can do the things that what we actually have seen during this webinar. And the next phase is that next year we will start seeing a new radio, 5G radio coming in, and the architecture between the 4G and 5G is it has been agreed that in this first phase the 4G core will be used with a 5G radio. So basically, dynamic profile controller can also control the 5G radio. Then in 2020 time, 5G core will be ready and it will be rolled out, and there we are getting the new network element into the game. So that's called the network slice selection function, NSSF. It's a really much the similar kind of a creature than the dynamic profile controller. And then going forward, we are actually seeing that these two, DPC and NSSF, they could actually merge together. Here is also good to know that the 5G core is not able to communicate with the 4G radio according to the current plans. So the 4G core will be there for a very long time. As we kind of what we saw in the big picture, that picking up the new radio technology will take a fairly long time. So with this, I will actually thank you Here is our contact information, so you can follow us on Twitter, LinkedIn, Facebook, and then use the more traditional email if you need to contact us. And we have even the telephone still, that if there is a need to talk. But with this, I will give it back to you, Brendan.
Thanks very much, Mika. That was great. We did get one question coming in, and this person asks, what concrete use cases are you working on with operators at present?
So at the moment we are working with this IPTV case. So that's in quite many countries the fixed infrastructure, fixed cables are not that great, and they still want to provide the IPTV service for all the customers. So instead of laying down fiber, we can actually use the LTE network, especially in the suburban and the rural areas. So that's obviously one. Then we have done an augmented reality use case. So that's for the field maintenance employees, that instead of using their hands holding the phone and trying to show that what's going on, they have actually a camera on their glasses, and then they can be given instructions through the lenses on the AR images, and then the obvious advantage here is that they will have their both hands free. And then the public safety. So we have been working years with the public safety communication research in the United States to develop the local control specification for FirstNet. So those are the most kind of advanced things what we are doing at the moment.
Very cool. Thanks, Mika. We don't have any other questions. If there are any, please don't hesitate to ask. The chat window is open for any questions that you might have. But in the meanwhile, I just want to thank everybody for joining us today. So we've also mentioned that there's a white paper component to this. The companion piece is the user-defined network slicing in practice, and that white paper will be on its way over to you as well today as a complimentary thank you, and we hope that you enjoy it. If you're interested in learning about how Cloudstreet can help you integrate network slicing into your network, we would be more than happy to discuss use cases and proofs of concept that would be specific to your network and your users. And so we'd be happy to set up a face-to-face meeting or call. Again, you can email directly mika.scarp@cloudstreet.co, or you can email me, Brendan, Brendan Walsh @cloudstreet.co. So with that, we thank you once again for being with us today, and we hope that you have a great rest of your day. And again, please keep in touch, and we look forward to the chance to interface with you again. Have a great one.